In this video, we'll talk about the standard load balancer provided by Microsoft Azure. So let's talk about the advantages of a load balancer. So any load balancer, we use the terminology called as a load balancer. There are many load balancers available in the market, okay, like NetScaler, F5 load balancer. Okay, like there are so many load balancers are available, but one of the load balancer provided by Azure, we call it as a standard load balancer. So in general, load balancer provides high availability to the application. So what does that mean by it? So we have an Azure virtual machine and an application running on the Azure virtual machine. So what happens if this virtual machine goes down? So the application will go down. Now we want to ensure that if the virtual machine goes down, we have another virtual machine which is going to serve the application. Now, to have that high availability, I'm building two virtual machines, which is having VM1 or what called as in VM2. Now we have two virtual machines which are running the same application. So the load balancer provides the high availability to the application. So what does that mean by it? So we can have a load balancer. So this load balancer can monitor the availability of the application, and it can automatically redirect the requests or forward the traffic to the respective VMs. So next session, it distributes the traffic across the backend servers or applications. So it's going to distribute. Now we have two virtual machines running the same application. So one primary goal is to achieve the high availability. So in case of one particular VM goes down, so we have the other VM up and running, the load balancer can still forward the traffic. At the same time, the load balancer can distribute the traffic. Let's say if the 100 users are trying to access the application, then it can distribute the traffic to the virtual machines like 50 users, through which we can achieve a better performance, achieve better application performance and better user experience. So what happens now? In some case, we would see that all of a sudden we have some 30,000 users are hitting the application. As we have two servers running the same application, we can distribute these 30,000 requests across these two virtual machines. So the load balancer is going to distribute the traffic, so which provides a better application performance and better user experience. It provides a single IP address or an FQDN name to the user. Now we have two virtual machines. We don't need to tell the user that what is the IP address of the VM1 and what is the IP address of the VM2. The load balancer will provide one unique IP address, which we called as a virtual IP in a load balancer terminology. So this is going to be a single IP. So it provides a single IP address or an FQTN to the user for every application, So one single load balancer, a standard load balancer, can serve multiple applications. A standard load balancer can serve multiple applications. So in this case, so we have this load balancer and these two are running one application. Running in one application. We have another virtual machines. A different application is running, which is requires a different URL. Now the load balancer can have a multiple and IP addresses and serve multiple applications. Now multiple. So for each and every application, it can provide a single IP address. Now this is a public IP, which is called as I would say, a 20.20.10. Some 15. And similarly, we have another IP address called as a 20.30. Something. So like this, the standard load balancer can serve multiple applications, okay, by creating one single one. Now this, a load balancer monitors the health of the backend servers or applications. Now what happens? Something goes wrong with this VM. Could be the application server which is running inside the virtual machine might be down, or the virtual machine got stopped unexpectedly, or the virtual machine is not responding unexpectedly. But the load balancer will keep monitoring the health of an application or the VM and ensures that if this particular backend resource is healthy, then only it distributes the traffic or forwards the traffic. For some reasons, if this particular VM is not responding, then load balancer understands that, okay, this resource is not in good condition. Let me forward all the traffic to the VM for that way. A standard load balancer can support multiple applications, multiple types of applications. I would say like you can do a port 3389 port, or you can run an 80 port, or you can distribute HTTPS traffic, or like in whatever we can call it is like either 8080 port, etc., etc., maybe SSH port. So it's not limited to only to the HTTP or HTTPS. So you can, based on the type of application, it can support, which is both TCP and UDP. So that is, it can support both in TCP bar UDP traffic distribution. So this load balancer takes the decision based on IP address and port number. So what is required now? So we use a terminology called as a front-end IP. Front-end IP. The front-end IP is could be a public or a private IP. So we also called as a deployment. Okay, the standard load balancer can be deployed as a public or a private, but based on that, we can have a front-end IP as a public or private. So which kind of situations we would have a public and a private IP? Three-tier architecture applications. These two VMs are serving in a front-end application, which are exposed to the internet. And we have another two set of VMs running in a backend application. Let's say VM3, or VM4, VM1, VM2. And we have another set of VMs, which is database application. So this is a front-end application, which is exposed to the internet. So which is needs to be accessible from the internet. And as part of the application, you have a backend application, which is not exposed to the internet, but where the front-end application will interact with the backend application, and whereas backend application will interact with the database application. Database application. Now, we need to have a load balancer, which can receive the traffic from the internet and can forward the traffic to the front end servers, which is running a front end application. But now there are two virtual machines running a backend application. Now I cannot configure the two IP addresses in the front end application. I need a one single IP. Now, in order to ensure the high availability, so we need to have a load balancer before the backend application. Now this is exposed to the internet, having a public IP address, and which needs to be accessible from internet. So this we call it as a public load balancer. When you're deploying it, we can deploy it as a public. And this, we can call it as a private IP address and private internal or this thing. So here this can connect to the one of the a subnet within our virtual network and can provide that. So when you have this kind of an architecture in your applications, then we need a load balancer which can listen the traffic from the internet and forward the traffic to the switcher, and we can have another type of load balancer, which is as an internal or a private, which can have a private IP and forward the traffic to this one. So what happens here now? The front-end IP, if you are deploying a public load balancer or an internet-based load balancer, your front-end IP will be a public IP address on which it is going to listen the traffic. So front-end IP is nothing but on which IP address the user traffic will be listened, will be accepted, I would say, or listened. So in terminology, load balancer terminology, it will be called as a listener in a general terminology. But in a generic terminology, I would say call it as an IP address on which user traffic is accepted or received we call it as a front-end IP. So when a user types, I would say hrms.acutelearn.com, to which IP the traffic has to go. Now there are two VMs serving the same application. but we have a load balancer. Now I'm configuring the HRMS dot this thing to a public IP, which is called as in 20.20.10.10 something. Now this is the a front-end IP on which user traffic is being received and a DNS record is being mapped. So the load balancer is going to listen the traffic on this particular IP address. If it is a private, so I would say that, okay, the private IP address could be like in 172.16.10.10. 10.10 and mapped to an internal load balancer and a DNS record is being created. I would say called as an backend app dot, okay, some acutelearn.com. Now this is on this particular IP address, the internal load balancer is going to listen the traffic based on the configuration on which port it has to listen. So during the deployment of the load balancer, we need to choose whether we want a public load balancer, that is internet-based load balancer, or private load balancer. Based on that, the front-end IP will get changed. Second is in the load balancer will have, we call this a backend pool. Backend a pool. Backend pool is nothing but a set of servers, set of virtual machines, I would say servers running the same application. Same application. So I would say, or a set of applications, a set of servers, a set of VMs running the application. Now, these are the two servers running the front-end application. These are the another two set of servers running the back-end application. Now, these are the two virtual machines which are running the same application. So this is what we call as a back-end pool. Back-end pool. Now, when I go here in this diagram, we have two different applications. Now, these two VMs are running a different application, and these two VMs are running a different application. So all these four virtual machines are not running the same application. So now in this, where we call it as a backend pool, a set of running the same application. So now this is one backend pool, a backend a pool, and this is another backend pool. Now, so at any given point of time, we can add or remove the VMs from the backend pool. So it means that today you are running two virtual machines, but these two virtual machines are not able to handle the load. We want to add one more. Then we can add one more virtual machine into the pool. The moment we add a virtual machine into a pool, then the load balancer will start distributing the traffic to the new virtual machine which has been added. For some reasons, we feel that, okay, then our load is very low. To save the cost, we want to remove the virtual machine 3. Then we can remove that. Now, the moment we remove the VM from the backend pool, then the load balancer will automatically adjust the routing of the traffic between these two virtual machines. So at any given point of time, so we can add and remove the virtual machines from the pool, or we can call it as an IP address, which is called as a servers. So that is the set of VMs running the same application, which are going to basically called as a backend pool. Now, in this kind of situations, I have two front-end IPs. The front-end IP one is in 20.20.10.15. Another front-end IP is 20.30.10.15. Then I have two backend pools. One backend pool is for this particular application. Another backend pool is for another application. So we can create a multiple backend pools, create a multiple backend pools. Pools. One backend pool can serve multiple applications. Multiple applications. So what does that mean by it? Let me take this diagram. So I have two applications deployed on this particular VM. One is running on port number 80, another one is running on port number 8080. So I have two applications running. So one is running on port number 80, and another one is running on port number 8080. To save the cost, so I'm deploying multiple applications onto the same set of virtual machines, but I still want to achieve the load balancing. Now, in this case, the application is running on a different port. So the load balancer can accept a traffic :80, and it can receive a traffic on 20.20.10.15 :8080. Now we can configure the load balancer in such a way that, okay, if a traffic is coming on a port number 80, forward to the 80 application. If a traffic is being received on a port number 8080, then forward the traffic onto the 8080 port in the backend. That's what a single backend pool, a set of servers, can run multiple applications. This is one case. A second case is in so yeah. So you have another virtual machines. I'm taking an example. Running application, multiple applications on the same port number. Because you might be doing it. Now what happens in this case? The standard load balancer cannot distribute the traffic or cannot decide the traffic to which port number it has to forward. Because it can listen only traffic on 80. It can forward to any one of the application, but it cannot forward to the both. It cannot take a decision based on the header or anything. So always the backend application should be differentiated. If two applications are running on the same set of servers or a backend pool, then we have to differentiate based on the port number. Now we have health probe, or we can call this an health check. So what is this health check? The load balancer will check the backend pool member is active or basically inactive. I would say whether the backend pool member is responding or not. For every 5 seconds, it will go and check that. So what this load balancer will do is, for every 5 seconds, it go to this VM and check whether the port number 80 is responding. It go to another VM and checks port number 80 is responding. See, if it is not responding like that for a period of 5 intervals, 5 seconds not responding, another 5 seconds not responding, another 5 seconds not responding, like that for 5 intervals, if there is no response from this particular VM, then the load balancer will treat that this particular one is dead. It will treat that, okay, this particular VM is not responding. So it will mark this as an inactive. And it will stop forwarding the traffic to this virtual machine. The rest of the traffic which has been received will be forwarded to this particular virtual machine. And it will keep checking it. Let's say for some reasons we have resolved this issue. The moment you resolve this issue, again the load balancer will start forwarding the traffic to these two VMs. That's how the load balancer will work. Okay, the health probe will will keep checking the health of this particular one. Load balancing rule, I would say called as a load balancing rule. We call inbound rule. So what is inbound rule? So the inbound rule decides on which front-end IP, on which port number it has to listen the traffic. When a request comes on this particular IP and this port number, to which backend pool it has to forward and to which backend port number. So in this case, my traffic should be received on this IP and a port number 80 should go to this port number backend pool 180. If a traffic is received in a port number 8080, and it should go to the same backend pool on a port number 8080. Now, the load balancing rule, the inbound rule, decides on which a front-end IP and port number the traffic should be listened or accepted, and to which backend pool a backend pool and port number the traffic should be forwarded. So the rule defines says that, okay, a traffic from an IP on a front-end IP called as this one and a port number called as an 80 forward to a backend pool 1 on a port number called as an 80. And a backend and another rule 1, this is what we call as maybe a rule 1. I can configure multiple load balancing inbound rules. I want to say on a rule number 2, I would say any traffic received on this public IP on a port number 8080 forward to the backend pool on a port number 8080. This port and this port need not to be the same, but what is the port number from internet we are going to hit the traffic and on which port the application is running. So that is what it should be like that. The inbound rule. And let's see that how we can. So I have two virtual machines. So we have a virtual network created and I have two virtual machines available. So what we need to ensure that first a web server is running, or I would say an application is running and configured on the backend pool members servers. Second is a port should be allowed on the NSG, on the NSG. So we need to ensure that the respective port is being allowed on the NSG of the VMs so that the load balancer can forward the traffic to the members. So first I'm going to the VM1. I'm taking the public IP of the VM1. I'm connecting RDP to this VM. Let me take another VM IP while that is connecting it. Let it get connect. So I have two virtual machines deployed. Let me go to the first virtual machine and deploy the web server. Let me install web application server. Just simply follow these instructions when you are practicing it. You don't need to be an expert on web server. Just for the practice purpose, you can just do a simple application deployment. Let me go to the second VM. So on both the VMs, I'm installing an IIS web server. So we have the web server installed. So let me go to the IIS, and I would see a default website running on a port number 80. Just open a notepad. Before that, let's go to just create two folders. I'm just create for testing purpose. I'm saying app one. I'm creating one more app two. Open the notepad. Put a message. Welcome to VM1 app one. File save as. Select all. Go to the path. I'm just selecting an app one folder and put it index.html. Next.html. Put VM1 app two. Save as. Go to the app two. Index.html. Select all files. Then index.html. I've just created a simple HTML files. Okay. So I'm going to the default website. Let me change the path of this folder to the app1 and restart it. I'm creating one more website, app2. The physical path of this is in app2 and runs on a port number 8080. So now I have two applications deployed in this particular one. One is on port number 80, the other one is on port number 8080. Let me go to the another VM and let me do the same steps. Save this as index.html. I'm saving one more file for app2 index.html. Now let's go to the IIS web server. Default website. I'm changing the path. App1. I'm creating a new site. I'm saying app2. Select the folder where this application. I'm selecting app2 is the application running on port number 8080. So I have these two applications deployed and these two virtual machines. So now let's go to the virtual machine 1. So I need to open the ports. Let me go here. I'm creating inbound port, HTTP traffic, port number 80. Allow from anywhere. I'm creating a one more rule, 8080 port, allow from anywhere. So let me go to the VM2 and I'm allowing port number 8080. I'm creating inbound port. I'm running at port number 80. So I configured NSG rules to allow the inbound traffic. Now let me go to the load balancer. So create a load balancer. So it's a standard load balancer. Select the resource group. The name of the load balancer, I'm giving a acute -public -lb1. Standard. We can see type internal or public. So public will have a public IP address as the front end, and internal can have a private IP. Public. This is regional, so which will be available within that region. So when you select a global, this load balancer can be available on another region also. Okay. In case of primary region goes down, the load balancer can be available on secondary region. So I'm selecting a regional. Next, front end IP. So add a front-end IP. So you need to create a new public IP. I'm giving it app1 front-end IP. Create a new public IP address. I'm saying app1 public IP. So now we created a public IP as the listener, or I would say front-end IP. Later point of time, we can add multiple front-end IPs, but during the creation of the standard load balancer, you need to have at least one front-end IP. Go to the backend pools. So where is the application? Click on backend pool. So we can just name the backend pool. I'm just giving pool one. We can give appropriate names. Select the network where your virtual machines are there. So either you can use the NIC cards or you can specify the IP addresses. So I'm selecting the next, click on add. So displaying the two virtual machines, select the NIC cards of these two virtual machines. Save it. So now we have inbound rules. So what is this inbound rule I set? So traffic received at this IP address and port number to be forwarded to which backend pool? So that is our inbound. So I'm going to this one, add a load balancer rule. I'm giving it app1 front-end IP address. On which IP address it has to listen the traffic. I'm adding the front-end IP which we created. Backend pool to which servers it has to forward the traffic. Backend pool. What is the protocol to TCPR? Port number. On which port it will listen the traffic from the users. Backend port on which port number the application is running on the backend servers. So in my case, so the application will be listened on a port number 80, and also the application is running on a port number 80 in the first application one. So that is the reason why I'm selecting 8080. And health probe, create an health probe. I'm saying HTTP. So it's going to check for every 5 seconds interval of time whether the port number 80 is serving it or not. So click on save, review and create. So let's go to you can click on load balancers and we'll see a load balancer. So I see a front-end configuration, the IP which we configured during this one. We see the backend pools, health probe what we created, and the load balancing rules. That okay, traffic received on the front-end IP. Now let's go to the front-end IP. Let me take this IP. Let me go to an HTTP IP address. Now we can see that the traffic is going to a VM1 app1. Let me open in another window. So VM1 app1. As there are no requests more number of requests. So the traffic is going to the VM1. If there are too many number of requests, then the load balancer will distribute the traffic across these things. Okay. So now let me go to the one more load balancing rule. I'm creating a one more load balancing rule. I'm saying called as an app2. I'm selecting the same front-end IP, same backend pool, but port number, I'm saying 8080. The backend application is running also on port number 8080. Health rope, I'm creating a new health probe, HTTP 8080, on which port number 8080. Now click on save. Now I create a one more load balancing rule. So what I said here in this rule is an traffic received on this particular IP and a port number 8080 forward to this 8080 on the backend servers. Now let me go to this one, colon 8080. Because the Windows firewall might be blocking the traffic. Let me open a port number 80 on the Windows firewall. Let me go to another VM. Because we allowed on the NSZ, but we didn't allow on the Windows firewall port. By default, 8080 will be allowed, but 8080 port is not allowed by default. So that is the reason why explicitly I'm allowing it. Yeah, now I see that, okay, VM1 app2. Let me go to the incognito window. We see VM1 app2. So now what happened here now? So we are able to receive the traffic on 8080 port and able to forward to the backend virtual machines. So I'm trying to say third thing. So I'm trying to add a one more front-end IP. I'm saying app2. I'm trying to create a new public IP for an app2. Now, third case, what I'm trying to do here is in rule 3, I'm saying called as a 20.20.10.16 example. I'm saying port number 80 and backend pool, I'm saying called as an 8080. I'm going to listen the traffic on this new public IP and port number 80, but I'll forward to a backend pool on the same backend pool, but on a port number 8080. So what happens? On the backend, the application is running in a different port number, but when we are listening or accepting a traffic from the users, the port number is different. So I'm going to this one. So I have the new IP. So let's go to the load balancing rules. I'm saying called as an app to LB. Front-end IP, I'm selecting an app to. Backend pool, same backend pool. Listen traffic and port number 80. Backend port, listening on 8080. Health probe check, save it. So the front-end listening port and the backend listening port need not to be the same. It can be different. Okay, it is matching another rule. That is the reason why. Let me delete this. App to backend pool, port number 18, port number 8080. So I'm taking the front-end IP. So earlier we were using 8080 port number. Now I'm not using 8080. I'm simply using an HTTP. So we can see called as an VM1 app. So this way you can create multiple inbound rules, inbound rules for multiple applications. Okay. So that's how we can configure a load balancer, the standard load balancer, and distribute the traffic among the multiple virtual machines.